Kejap, where is soil water? Tak nampak lah. So formation, okay, this one. Okay, nampak tak slide saya?
Nampak.
Okay, so soil water, okay, so Sekejap. Tak betul ni. So basically untuk final exam memang you have to study sebab saya tak ambil direct, ada yang sikit direct daripada lecture notes, tapi soalan saya macam little bit you kena fikir, which is more like application. So you have to understand the concept, try to think. The theory is from the slide. Maksudnya fundamental things yang fundamental, tapi sometimes the question is applications. Okay, so soil water. Okay, so soil water holding capacity, kena tahu how the soil sustain in soil at field capacity kan. So because of the capillary forces. So capillary forces ada dua action, satu adhesion, satu cohesions. Okay, so why water is related to texture kan, sebab kalau ruang-ruang rongga dia lebih kecil, dia punya capillary and capillary actions are more. Okay, for example eksperimen yang ni. Okay, kalau you nampak capillary action dia sama dengan equal to field capacity. Faham tak saya cakap? Kalau tak study lagi tak faham lah tu. Okay, capillary action is equal to field capacity. Maksudnya lepas hari hujan, 2-3 hari lepas hari hujan, air tu ada kat dalam medium tanah secara melawan gravity. Jadi that is because of the capillary action. Okay, so capillary action adalah sangat berkait dengan texture. Okay, sebab tu kawasan air, kawasan pantai atau bukan soil yang jenis sandy soil, dia tak boleh hold the water much in comparison to clay and loam. Okay, so loam ni is the medium textured types of soil. Okay, so you have to remember capillary actions ada dua forces yang bertindak dekat dia, which is the cohesion and adhesion. Okay, and it's related to texture. Okay, then you have to understand the terms of infiltration, water percolation. Okay, how soil structure affects the water movement. Okay, ada yang ni yang ni dah keluar dekat dalam midterm kan? Ke belum? Confused sebab saya ada ajar lagi satu kelas. Okay, so basically it's related to soil structure. So you have to understand what is soil structure, why is it important. Sebab dia ada macropores. Okay, dia allow macropores. Macropores is a very important element when you talk about water infiltration dengan air circulation. Dia bukan berlaku di micropore, dia berlaku di macropore. That's why aggregations is very important. Kalau you nampak tanah tu mudah bergerak, the soil is said to be poor aggregates. Okay, so dia mudah sangat digerak. Aggregations adalah ketahanan tanah tu untuk melawan dia daripada dirosakkan. Macam tu bahasa dia. But the term here you can read here. Okay, so understand the functions of why it is important of what is the importance of soil structure and how it is formed. Okay, so it is back related to organic matter. When you are answering your question, especially yang KBKK ataupun you have to interrelate, please interrelate. You pun kena fikir. Okay, contoh macam air. Air berkait dengan soil structure, berkait dengan soil texture. You have to link that. Okay, the problem is sometimes, to be honest lah saya cakap, memang ada yang tengok lecture note. Okay, because jawapan sebiji and you can't relate that. You tak boleh nak relate pun that jawapan. That's why you cannot get the full marks. Sebab from there I can see your understanding. Okay. Okay, so the terms lah, terms infiltration apa, percolation apa. Okay, then you have to know types of soil water. Okay. Then okay, ni tak ada apa. This term. Okay, what is field capacity, what is saturation. Okay. Then soil water potentials, how it flows daripada tinggi kepada rendah kan. Okay. So daripada tinggi, walaupun tinggi dia tetap negatif. Okay, so what is the water potentials of a field capacity? It should be negative 0.33. Okay, that is field capacity. You have to remember. And soil at saturation, dia tak boleh pergi 8 nombor dia ataupun 8 megapascal ataupun 8 bars. No such thing as positive value. It should be soil at saturation, maksudnya penuh dengan air macam empangan tu, the water potential is zero. Dia start dengan zero. So bila dia turun daripada macam air terjun tu, dia dah jadi negatif. Sebab from zero dia akan pergi ke arah yang lebih negatif. Okay. So measuring flow water ni tak ada apa. Okay, sambil tu boleh tanya kalau ada yang nak tanya. Okay, then the next topic is soil water, soil aeration and temperature. Okay, jap. Soil aeration and temperature. Sekejap. Where is soil aeration and temperature? Nampak tak mana? Okay, here. Okay, so soil aerations and temperature, basically kita kena tahulah what is soil aeration, apa yang chemicals, biologicals and physical factors that affecting the level of oxygen. Okay, so tiga principal factors, macroporosity, water and oxygen consumption. Okay, paling penting. Faham tak saya cakap ni? Saya just nak refresh balik apa yang penting Okay, dalam ni yang paling penting, yes, this one. Okay, the reductions and oxidation state. You don't have to remember the formula, tapi at least you have to know. Okay, oxidation meaning that there is a loss of electron. Then siapa ambil that electron? Okay, for examples kan. Okay, so oxidations is a process of losing electron. Okay, so and the oxygen will receive the electron. Okay, siapa yang hilang oxygen adalah the ferrum, oxygen. Yang hilang the electron is the metal. Okay, so this one is very important, the understanding. Sebab it doesn't happen only to ferrum but also magnesium, but the concept is the same. And the most important part dalam ni adalah this one. This is very important to know the levels because it affects in explaining why kalau hari berair, kenapa nitrogen tu hilang? Kenapa kalau banjir berlaku greenhouse pelepasan gas rumah hijau? This explain. Okay, so saya dah explain dah. I'm not going to explain in details. Tapi kalau ada yang nak tanya, yes, you may ask. Okay, kalau you tak tanya, I assume you understand and you akan start sendirilah kan. Okay, so this is important parts of aeration. Saya nak you faham the state. Okay, state ni maksudnya dia akan attack oksigen dulu. Bukan dia akan attack elektron tu, oksigen akan terima. Lepas tu oksigen dah habis. 3-4 hari dia akan attack nitrate. Lepas beberapa hari dia akan attack manganese oxide, ferrum, sulfate and lastly is carbon dioxide. Okay, so the some of the questions might be application. Contohnya kenapa greenhouse gases kalau banjir apa jadi? What will it affect? Which is tak ada kat dalam lecture note saya. Hari banjir, current issue sekarang kan, hari banjir. Kalau you tengok dekat you datang Kuantan, kiri kanan tu pokok oil palm yang mana kat bawah-bawah tu mati. Bayangkan banjir tu seminggu je tu lama kan. Tapi dia mati dah, tak boleh nak hidupkan dah. Okay, so what does it affect to the industry ke? Kalau you nampak dia boleh menyebabkan nitrate dalam tanah hilang, but you tak boleh cakap nitrate dalam tanah hilang je because of flood. But you have to explain this. Okay, kenapa dia flood tak bagus? because of it release the carbon dioxide, it changed the carbon dioxide from carbon dioxide to methane. Methane is a greenhouse gases which you have learned, I've taught you, kan? Okay, so yang tu part paling penting. Then decompositions of organic matter berkait dengan levels of oxygen. Okay, so these are some of the importance yang in details, tapi the idea is pertukaran metals tu tadi. Okay, so it also can be indicated by colour. Jadi boleh tahulah yang warna merah ni is oxidized. Okay, so oxidized forms of iron, apa Fe3 plus, reduce Fe, kan? Okay, so some of the situations yang you boleh nampak selalunya kat dalam kawasan sawah padi. These are some of the examples. However, yang ni by ni you akan faham lah the concept, kan? Okay, so sulfur pun sama. These are some of the nutrients involved lah, which is closely related to aeration. Yang ter-effect lah kalau oksigen tak ada. Okay, so you have to know it is related to decomposition process, toxic elements, the forms of iron, iron, manganese, nitrate. Sometimes contoh macam nitrate kan, kita nak dia berada dalam NO3 untuk pokok boleh serap. Tapi hari banjir, okay, so dia jadi N2. That affects the form of the nitrogen. Okay, dan dia menyebabkan nitrogen tu tak available dalam tanah. That is how the aerations is important. Okay, so roots of course because they do respiration, decomposition of course sebab you nak a complete decomposition process, and the greenhouse gases is related macam saya cakap tadi, CH4 tu daripada CO2. Okay. Okay, ada soalan tak? Do you have any question? Idea. Okay, so the next is chemical properties of salts. Ni is the core of everything. Semua benda saya nak tanya kat dalam ni. Jadi kena hafal satu-satu slide saya. Ini ni. Sapra 7, 8. Where is my 8? Okay. Okay, so soil chemical properties, start dia adalah of course you kena tahu crystallite. Kita start dengan the most important yang explain everything. Okay, which is the soil colloid. Apa 4 types of the soil colloid? Apa definition soil colloid? Okay, so apa itu colloids? Dia boleh jadi clay, dia boleh jadi humus, dia boleh jadi crystalline ataupun amorphous. Okay, selalunya size dia sangat-sangat kecil. Okay, so what is the surface area ni, you faham lah, surface charges. Okay, apa properties dia? Okay, what is the properties? Because it can carry cation exchange site, because it has cation exchange sites, it has the ability to exchange the cations. Okay, but what is that types? Okay, so yang ni you kena tahu apa itu cations, apa itu anions. Okay, so what is exchangeable? Okay, so exchangeable ni maksudnya KCAMG ataupun neutron yang boleh disaling bertukar ganti dekat site of the clay. Okay. Okay, so types of colloids yang paling penting 4 jenis, tapi yang paling penting that you have to focus later is crystalline silicate clay. Okay, so crystalline silicate clay terdiri daripada apa? Tetrahedral sheet satu, watch, and also we have octahedral sheet. 2 ni je, takkan jangan tambah-tambah yang lain. Okay, so apa structure tetrahedral sheet? You have to understand, hadamkan rupa dia and kokot kalau kena lukis ke apa kan. Okay, then octahedral sheet. What is the criteria of the octahedral sheet? You ada berapa oksigen kat tepi dia, berapa dekat tengah tu ada apa, aluminium ke, magnesium ke kan. Okay. Okay, so tetrahedral ni aluminium, magnesium untuk octahedral. Kalau tetrahedral, silikon yang duduk tengah-tengah. Please remember the core structure of it. Okay. So macam mana susunan dia? Susunan dia tak adalah saya suruh lukis yang 3D ni kan. Tapi you have to understand, ada yang kalau 1 to 1 macam mana, 2 to 1 silicate clay macam mana. Okay, 1 to 1 apa atas sekejap lupa. 1 to 1 berapa, siapa atas, sekejap. 1 to 1, Allahu Akbar. 1 to 1 tetra atas, okta bawah. Okay, so ada dua ni je, tetra, okta. Tapi kalau 2 to 1, dia ada tetra, okta, patah balik tetra, okta. So apa beza dia antara 1 kepada 1 dengan 2 kepada 1? Kalau 1 kepada 1, because oxygen mixed dengan H, O dengan H, dia adalah hydrogen bonding. Jadi dia rapat. Okay, so tak boleh ada air ataupun cation exchange. Compared to tetra jumpa tetra, maksudnya O jumpa O, oksigen dengan oksigen molecules, dia adalah van der Waals dan ikatan dia agak tidak strong. Okay, so akan ada air dan juga nutrien boleh lalu dekat situ. However, 2 kepada 1 pun penting. Okay, so you have to remember apa itu 1 to 1 types of clay, apa itu 2 to 1 by definitions. And also you have to understand, you have to know what is the name of the crystal structure. Okay, contoh 1 to 1 kita ada smectite, 2 to 1 kita ada beberapa jenis, vermiculite, mica, kita ada elite. So apa karakteristik dia? Saya dah cerita dah, ada yang K je nak duduk kat tengah-tengah tu. Ada yang for examples macam vermiculite ni. Vermiculite ni dia punya behavior, dia bagi pertukaran air dengan cation, which is very good. Vermiculite paling bagus dalam casta clay. Okay, yang kaolinite tu jangan cakap lah, memang dia kedekut lah sebab dia 1 to 1 dengan dia memang takkan bagi. Tapi fine mica ni pula, dia bagi tapi K je duduk kat tengah-tengah dia. Tapi in other words, clay jenis ni kaya dengan potassium. Okay, so that are some of the examples ataupun things that you have to remember lah, jenis-jenis colloids, okay, structure of the colloids and also types of each soil colloid, okay, yang dalam crystalline structure tu Okay, then this saya ni kena hafal nampak sampai 3 saya letak so that you can understand. Okay, so you have to also understand. Ya.
Yang smectite tu dia tak bagus ke? Kurang
smectite ni dia kalau bila kita cakap kan, okay, which one has a very good CEC? Of course, jawapan dia vermiculite. Because kalau you baca kat bawah ni, dia expanding. Dia ni kalau jenis smectite ni, tanah liat dia tu kan, okay, tanah clay dia tu, you tak boleh buat labu sayung tu. Labu sayung air tu kan, yang simpan air tu. Sebab dia macam ada jenis tu kalau hari hujan, you nampak kan dekat clay dia tu, dia macam lama sangat dia takungkan air. Sebab dia hold the water very long dengan dia allow the water to be dekat tengah structure dia. That is not good. Memang dia CEC tak bagus. Meaning that you have to remember the properties of each clay. Smectite dia air dia maximum swelling. Vermiculite have a good CEC. Some swelling, maksudnya medium swelling. Yang ni minimum swelling, tapi problem dia dengan fine mica ni pula adalah K dia nak duduk tengah-tengah. Okay, so chloride pula apa? Minimum swelling and ada hydroxide sheet dekat tengah ni. So what is the problem with the hydroxide sheet? Okay, so you have to faham lah, bukan faham, you have to remember the behavior of each clay sebab dalam clay sendiri dia berbeza. Okay, faham tak?
faham.
Bila cakap tentang CEC, a good types of the best type of clay is vermiculite. Macam tu. Mungkin saya akan tanya kan macam okay, show me which one dalam 3 ni is cannot exchange cation. Of course, kaolinite tak boleh, mica tak boleh, something like that. Okay? Okay, then you kena faham tentang what is ion exchange sebenarnya. What is the importance of ion exchange? Sometimes contoh perangai mica ni dia boleh pegang K. Dia ada CEC which dia boleh pegang the K, tapi dia nak pegang K je. Dia tak nak pegang calcium semua-semua. Okay, so the importance is that it can also exchanged. Bukan hanya whole cations. Okay, these are two different words. One is to exchange, one it holds. Okay, so kita tak nak yang whole sebab sometimes akar pokok ni dia tak boleh lah pergi celah-celah structure tu untuk ambil K tu. Kan? Dia have to be in soil solution. Contoh macam you ada satu cawan, okay, you kacau tanah tu dengan air and K tu dia terapung, dia keluar daripada structure tu, dia terapung-apung kat dalam air tu. Okay, that is exchangeable cation, okay, which is dia boleh, tanah ni dia tolong pegang sekejap je. Contoh bila air hujan dia releasekan balik dekat dalam soil solution dan pokok boleh serap. Pokok tak boleh lah pergi kat tanah, okay give me. Tak. They have to release and that one can take. Okay, so that bila dia release, siapa yang akan duduk tempat tanah tu balik? And that is very important to understand the theory of it. So kalau you tengok balik siapa nak duduk kat tempat CEC tu lepas K tu keluar adalah apa yang ada kat dalam tanah tu. Kalau tanah tu semakin berasid, H+ akan duduk kat tanah tu. Betul tak Syairin?
Betul.
Kan sebab H+ remember siapa yang paling banyak dia akan duduk satu. Okay, the more the concentrations of that element, the more possibility that it will sit at the exchange site. Satu. Nombor dua adalah kekuatan dia. Ingat tak? Siapa ingat yang mana? Zoharis, ingat Zoharis? Ingat tak? Mas Rizal, ingat tak yang mana? Selain daripada tu, apa lagi yang menentukan siapa duduk kat CEC site tu? Mas Rizal.
Ya, Doktor.
Apa soalan saya tadi?
Yang tentukan dekat CEC site tu.
Siapa yang duduk situ? Satu saya dah cakap dah, siapa yang bagi positif tu. Ya Allah, dia tutup mic dia. Apa nombor 2-nya? Jawapan, tak ada jawapan pun.
Tengah fikir sekejap.
Siapa nak jawab?
Aluminium ke Doktor?
Ya, saya faham. Betul Miss Rina, tapi apa nama tu? Betul. Aluminium yang nak ditutup.
Charge of the cations.
Charge of the cation kurang tepat.
Hydrated ionic radius the smallest.
Betul. Yang tu kan. Nanti ataupun kita panggil cation selectivity. Okay. Yang lagi small, lagi dia sedang mudah tertarik duduk di kawasan CEC site. So yang paling smallest selalunya H+, diikuti dengan aluminium, dan saya tak ingat, lepas tu kita ada calcium, magnesium, potassium paling dekat bawah, dan diikuti dengan nitrate. Okay, so dia ada ion selectivity nama dia. Okay, clear? Okay, apa ni Ni kenapa lecture 13 ni? Okay, so it's very important to understand that. Okay, siapa yang duduk siapa ni. Principle governing the cation exchange reaction is important. Okay, so apa teori atau apa teori dia? Ada 4 teori Okay, ratio loss, apa lagi banyak. Okay, cation selectivity and semua tu lah 4 tu. Okay, then calculation. Calculation sebab last time saya tak dapat nak ajar. Kalau face to face saya ajar calculation tau. Tapi dengan you all, I just hope that you can understand the theory of the calculation. Saya pernah ajar jugalah kan. Okay, so tapi saya tak ada tanya dekat soalan exam. And CEC of the soils you have to tengok ni yang ni lah. Siapa paling banyak sebenarnya. Kalau nampak organic matter, humus, tengok around 200. Okay, siapa yang paling sikit? Of course, kaolinite. Kaolinite sebab apa? Sebab dia apa? 1 Nasrin? Why kaolinite paling rendah sekali? Wano Nasrin.
Ya doktor.
Kenapa kaolinite paling bawah ni?
Sebab dia punya
Punya apa? Sebab dia one type of clay. Kan? Cuba tengok. Kalau vermiculite saya cakap tadi kan, dia has high CEC. Nampak ni vermiculite duduk kat mana? Okay. So sandy loams paling rendah sebab dia pasir. Okay. So iron aluminium oxide pun paling rendah. Tengok balik dekat dalam types of soil colloid kita ada. Iron and aluminium, apa yang namanya? Sequartzites Okay, so tengok balik yang tu is important. Okay, ni semua okay. Unit CEC apa? Okay, centimoles per C, kg semua tu kena ingat. Okay. Okay, so next lecture 9. Okay, lecture 9. Okay, kita dah masuk acidity. Okay, so first thing first you have to understand kenapa kita cakap pH ni adalah ukur pH je you boleh understand dah apa akan jadi dalam tanah tu. Okay, we call it as a master variable. Why? Okay, so because it affects nutrient availability. Okay, so apa tu proses acidity and alkalinity? Okay, so ada dua. Kalau acidification, of course there is a production of H+. Production of H+ maksudnya makin banyak H+. Kenapa makin banyak? What is the activity that contributes to the H+ production? You have to remember. Okay. Okay, washing away of non-acid cations. Macam saya cakap, calcium, magnesium and potassium ni yang bagi karakteristik yang apa? What is that? Berasid. Okay, jadi kalau calcium, magnesium bagi sifat berakali. Okay, so jadi siapa yang berasid? Aluminium, H+, they carry the acid properties. Okay. So pools of acidity kena understand apa residual, apa aktif, apa exchangeable, dekat mana dia berada. Ni yang saya cakap ni dia kena dalam keadaan yang dalam solution. Okay, ada yang exchangeable dekat sini dan sini. Okay. Okay, kalau untuk nutrient adalah kawasan yang exchangeable dengan active acidity absorb dekat exchangeable site dengan dekat soil solution, nutrient to available for the crops. Okay, so what yang ni kena ingat, acidifying process, apa aktiviti yang menyebabkan tanah semakin berasid. Okay. And please, kalau saya kata describe 3 activities, of course you have to give the name of the activity satu and the description. Kalau sebab 1, 2 markah. Unless kalau saya cakap state 3 process of acidifying soil. Maksudnya you state je lah. Kalau describe, you kena describe atau you briefly explain ataupun explain. Okay, tengok pembahagian markah tu macam mana. Kalau 1 markah tu selalunya state is 1 markah. give 3 examples. Okay, satu markah tu pendek lah jawapan. Tapi kalau 2, 1 jawapan and 1 explanation. Okay, clear? Okay, then ni proses-proses dia lah. Kena ingat. Okay. Role of aluminium in acidity. Yes, you have to remember macam mana the process of the attack and what is the form of the aluminium yang toxic tu. Okay, kalau kat sini kita ada Al3 plus toxic, AlOH2 plus and also AlOH2 plus. Ada 3 jenis toxic ion, toxic form of toxic form of aluminium. Okay, kalau kita nampak sini yang ni paling toxic, AlOH2 plus dengan yang ni. Yang ni atas bawah daripada 6 dia dah yang neutral punya, dia tak berbahaya. Okay, dia start berbahaya bila dia jadi sini 1, 2, 3. Okay. Okay, aluminium toxicity. Okay, then liming. Last 9, 10. Okay, so liming, of course you have to understand apa proses apa yang kita gunakan, which selalunya kita pakai liming materials, and apa dia punya reaction. Yes, you have to understand. Okay, siapa ganti siapa, apa yang dia hasilkan. Okay, so apa kebaikan letak limings. Okay, yang ni tak. Okay, so organic matter is important, how it can ameliorate the aluminium. Okay. Okay, then we put gypsum. Apa perbezaan you pakai calcium carbonate dengan gypsum? Kenapa gypsum digunakan hanya untuk combat the aluminium toxicity? Okay, so apa function gypsum? Okay, so yang ni lah, yang ni okay. Yang ni I think you dah belajar dulu. Okay, 10, 11. So organism tak ada apa, you kena hafal je lah. Dia lebih kepada hafal dan tahu types of bacteria, fungus, apa function dia, effect dia kepada biological, physical of the soils and also the chemical properties of soil. Ada kan? Okay, then lecture 12 and 14. Sekejap take tu sekejap. Okay. Compound science. Okay, then kita ada soil nutrient and fertility. Of course important. Okay, yang paling penting sekali understand what is the roles. Okay, nitrogen cycles. Salah eja. Sorry nanti betulkan. Okay, nitrogen cycles is important. Apa sumber-sumber dia? Ini the keywords kena hafal. What is mineralization? What is immobilizations? What is nitrification? What is denitrification? How is the process occur? Ada yang ada oksigen, ada yang kehilangan oksigen, ada yang hari panas, contoh macam volatilization, the losses of nitrogen from solid to gas, that is volatilization. Okay, so gas is ammonia. Okay, then understand what is the difference between mineralizations and immobilizations, how it affects the nitrogen level in the soil. Okay, okay, what controls the ni? Okay, so what bacteria involved? Nitrosomonas and nitrobacter. Which part is nitrosomonas? Which part is nitrobacter? Nitrosomonas act first. Okay, nitrosomonas tukar daripada ammonium kepada
Nitrate.
NO2. Okay, nitrate. Lepas tu nitrate kepada nitrate. Okay, thank you. Okay, so nitrosomonas act first, then nitrobacter. Okay, so denitrifications occur. Why? Because there is losses of oxygen. Okay, volatilizations of ammonia. I have explained one by one last time. So ammonifications, nitrogen fixations. Maksudnya sources macam mana nitrogen datang and causes that cause the nitrogen losses. You have to understand the term also. Okay. Okay, managing nitrogen, phosphorus pun sama. What is the problem? Phosphorus ni is very sensitive to pH, kan? Okay, dia suka sangat. Sekejap dia bergabung dengan aluminium, sekejap lagi dia bergabung dengan kalsium jadi compound. So what is the available form of the phosphate is also important. Okay, what is available from oil nitrate, sulfur, semua tu. Okay, this is nutrient yang involve cycles. Okay, potassium pun sama juga. What is the losses of the potassium? What is the input of the potassium? Okay, what is the problem? So dalam ni ada problem, sources and how it is lost and how you can enhance the that particular nutrient. Okay, so sulfur. Okay, so ni dia relate dengan microorganisms because I want you to relate back that the cycles involve the microbes. Okay, dia tak boleh bergerak, dia tak boleh seorang. Okay, so ni pun sama je lah macam microorganism, apa ni, yang organisms tu kan. Okay. Okay, so how the fungus ataupun actinomycete ni tadi helps in water holding and also the structure of the soil. And sometimes they provide substances, gibberellins, antibiotics which promote plant growth. Okay, so what is the importance of the microorganisms to the soil nutrient, to the soil structure and also to the biological properties of the soils. Okay. So ni semua contoh-contoh, yang ni panjang sikit because it combines 2 weeks punya ni. Okay, last one, lecture 13. Lecture 13 kita dah belajar lecture 13, it's related to organic matter, very very important. Okay, so what is organic matter? How so organic matter is a process of decomposition which use oxygen. So it is a oxidation process. So it needs oxygen. So the most important bila cakap pasal organic matter adalah how it affects the soil quality. So bila saya tanya soil quality, you should explain what does it the interrelated of the functions of biologicals, chemicals and the physical properties. Okay, so one by one saya dah terangkan kat dalam ni apa chemical properties, apa physical properties dia. Okay, so what happened if the soil, the organic matter did not decompose in aerobic conditions? Okay, what does it produce? Okay, tapi yang paling penting apa function dia itulah. Okay, and also C to N ratio. What is mineralization? Mineralization maksudnya menghasilkan nitrogen untuk tanah, which is very bagus yang kita nak. Immobilization adalah quality organic matter yang tak bagus dan menyebabkan immobilizations of N. Maksudnya kehilangan N dalam tanah tu. And what is the good ratio. Of course, the good ratio is around 24, 25, 26, 27, 28, 29, 30 sampai macam tu. Okay, so around 25 pun yes. Then apa jadi kalau C to N ratio 500? Is it good? So what is the process? Of course, dia akan jadi immobilization, kan? Immobilization, mineralization kena faham, and of course how to maintain this organic matter in the soil. Okay. Yang how is the soil? Okay, yang ni okay lah, boleh baca. I just highlight which is the important things. Okay. Okay, that's all. Ada apa-apa nak tanya tak? Untuk soalan final, semua topik tadi cover. Banyak markah dia, saya rasa dalam 90 macam tu kot. Okay, so macam saya cakap lah, kalau soalan tu describe, ada 2 markah, 1 jawapan, 1 explanation. Okay. Kalau jawapan tu saya cakap state 3 proses, state je lah. So ada 3 je lah proses tu, 3 markah. Okay, so kalau saya kata interrelated, so kalau explain essay, okay, it have to be interrelated, you have to think, try to connect one component to another component. Okay, which is yang related lah. Okay, so ada soalan tak? Kalau tak ada soalan, kita boleh proceed to our quiz. Shairina.